Hello friends, welcome back. So today I am going to discuss about the thread safety in Node.js. It's going to be very important discussion, and here we are going to discuss about the topics like whether the Node.js is single threaded or multi-threaded. If it is multi-threaded, can we manage the thread programmatically? Third, does the Node.js has any built-in thread pool mechanism? Or what is the main thread? How the thread worker is different from the main thread? In what scenario the thread pools are being used? Can we use it programmatically or it is being used automatically through the Node.js? And pros and cons of using the worker threads. So this is going to be very informative, and it's a request from the viewer to be with me till the end of this video. Node.js, it's a very common myth that Node.js is a single threaded, but it's not true. Node.js is a multi-threaded. So this can be better understood by this picture. So here if you see, there are the multiple clients or user, client 1 to client 10, and they are raising the multiple requests. For example, request 1, request 2, request 3, and request 10. Now these requests are coming under the event queue, and this event and the request under these event queue are being handled by the event loop. Now this event loop is basically taken care by a single thread, and this single thread is basically nothing other than the main thread. So this main thread is taking care of this event loop and all the requests. So whether it is request 1 or request 2 or request 3, all these requests are being handled by the main thread. But there are certain scenarios or there are certain conditions where event loop is not able to handle the different tasks under that request. So what are those tasks that event loop is not able to handle it properly, or if it will try to handle, then it will get stuck? So generally what it does, it pass those tasks to the thread pool, built-in thread pool under the Node.js. These built-in thread pools are basically built by using the C++, and these thread pools are being managed by the livuv. So what are those tasks that are being forwarded to this thread pool by the main thread? So this can be understood here. So these are the tasks. So if it is a IO intensive work, for example, if it is a DNS lookup or DNS lookup service, or if it is any file handling work apart from sync functions, if it is a non-sync functions, means if it is a async function, then it will be passed on to the livuv thread pool. Similarly, if there are some CPU intensive work, like if we are using the crypto libraries, for example, crypto.pbkdf or crypto.script, crypto.randombytes, in all these functions, the control is being passed on to the thread pool, and threads under this thread pool is taking care of these kind of work. Similarly, if we are doing some gedlib, if we are using gedlib, then in that case also our thread pool is playing the important role. So this is very important URL, and here basically it's being discussed in detail that what is the event loop and what is the thread pools here, and in what's how we should write our code to utilize this thread pool in very better way. So it's a very important discussion here in this URL, and our viewers can go through it. Now let's come back to this image. So here control in all those three scenarios, like IO work, CPU intensive work, control is going to the thread pool, and thus once passing the control to the thread pool, then this main thread becomes free, and then the main thread starts handling the other requests. So for example, if request 1 is having some CPU intensive work, for example it is having some utilizing some crypto library, then control main thread will pass that control to the thread pool, and thread pool, one of the thread from this thread pool, will start handling it, and by that time the main thread will become free, and then it will start handling the request too. So that's way the main thread keeps handling all the requests, and whatever it seems that it's gonna be blocking kind of task, it's gonna be IO intensive or CPU intensive work, then it pass on those kind of work to the thread pool. So here all these things are being handled automatically inside the Node.js, and till here we have understood that Node.js is not basically the single threaded. Internally there is a thread pool and having the multiple threads, and these multiple threads are doing some CPU or IO intensive work. So first let's understand how this event loop, or how our main thread is getting blocked because of some work, because of some CPU intensive or IO intensive work. So if event loop is able to identify, if main thread is able to identify those kind of tasks, it will pass on to the thread pool. But there are some scenarios where it will not be able to identify, and it will start handling those kind of huge tasks, and it will get blocked. For example, if we come to this code here, so here if you see, I have created two routes. One is non-blocking route. Here I am just returning the message that this is non-blocking API, but there is another route that is the blocking, and here I am running a very huge loop, so it's a kind of blocking. And here our main thread will not be able to identify that this should be handled by the thread pool, and our main thread will start handling it, and thus our main thread will get blocked here, and it will not able to handle the other request, and then all other requests will have to wait till the completion of the first request that is coming here. So this can be understood here. Our server is already running. Let's stop it. I have stopped this server and I'm running it again. Okay, our server is running on 3002 port, and if I'm coming here, so this is non-blocking, and if you see, it is giving the response very quickly. It is giving very quickly the response, and now I am running the blocking API, blocking route. So as soon as I have run it, it start processing it, and it is running it. It hasn't returned the response, it is still processing. Now I'm going to send another request to non-blocking. So see, it has also got blocked. That means it is waiting. Here our main thread has been occupied in processing this request, and thus main thread is not able to handle this request. And this even this is non-blocking API here. Just we are returning one message, but this API is still waiting. So this can be managed, or this can be handled if we are using threads here. So to achieve this, I have created another API here. If you see what I am doing, I have used this library, that is the worker threads, and this is coming inside the Node.js. No need to install any new package. Node.js 10 onward this is available. So I am just requiring it, and from here I am getting worker. From this worker I am creating one thread. That thread I have given kept it under the variable worker, and to create any thread we will have to pass a file name. In that file name, this file name can be anything, and in this file name basically we have kept our this logic, that is logic of handling this huge task. So that I have kept here. So that I have kept here, and here in this task I am passing some data. So this is my data, and here after creating this thread, I have I'm listening few events that are being emitted from these events. So first one is the message. So once our task is done, once our task is completed, then this thread will raise one event that is named as a message, and it will give the data that is generated by this thread, and that data we can do whatever we want to do with this data. And if any error is happening in the code inside that thread, then inside that task, then it will raise error message, error event, and we can handle that error event here. And once everything is done, everything is completed, then it will return exit. Exit means this thread, the work, the task of this thread is done, and now this thread will be destroyed here. So this is how it is we are creating the new thread. Now let's go through this file, that is worker.js. So inside this worker.js, again from worker thread, I have taken two classes, that is the parent port and worker data. So parent port is basically used to publish the messages, that is publish the events once our work is done, and worker data is basically to get the data from the parent thread, from parent or from the main thread. For example, from here whatever data we are passing it, that data is coming to this file through the worker data. Okay, now here we have created one function count2, and in this function we are passing this data, whatever the data is coming here, that data is being passed here, and then we have added our logic here. So once this function is completed, it is giving the data to the result, and then we are publishing one event by using the post message, and then by using the post message, and then that data is coming here, and we are just returning the response. So let's see how it is working. So I am running the node app2 here. This file name is app2.js, so I'm running this one, and it has started. Now if I'm coming here, first I'm running this non-blocking. So yeah, non-blocking is running properly. Now I'm running this blocking API. So if I'm running this blocking API, yeah, it's taking time and it's still running. So, and now it is being taken care by the separate thread. So our main thread is free, and if I'm raising any other request, then our main thread should be able to handle it. So let's see this. So yeah, our main thread is able to handle this. Now let's run it another request. Let's pass the another request for the blocking API. Yeah, so all if you see, all are still running, but even in that case, if we are even in that case, our main thread is free to handle all other requests that are coming. So this is the benefit of using the threads if we are having some huge task, and if we don't want to get our main thread blocks. One more thing that I forgot to say here, that here if what if we put these under one functions. For example, here if I am creating one function like say async. Yeah, so what if we create a function like async, and then we are returning a promise. Under this promise we are doing this huge work, and then we are keeping the await block here. If we are doing this, then whether this will make our main thread available to handle the other request till that until this is running. That means our main thread and this work can run in parallel without interdepending on each other. So yeah, it's our viewer can try this, and let me know in the comment what you are finding it, if you are trying this one, whether it is working, whether it is making your main thread free. And try this one, and let me know in the comment section. So apart from this, we can understand what are the pros and cons of using these thread. Makes our main thread available for the other task, and here main threads shares the memory with the main process. So generally all the threads runs in the main processes, and it can interact with the main process. It can take data from that processes, and it can pass data to that process back by using the events, as I have shown you in the example. And it can shared data by using the array buffer or shared array buffer also. And creating a worker thread is lot cheaper than working on new processes. And what are the disadvantages of these worker threads? So overuse of the worker threads from built-in thread pool exhaust the thread pool. So as I have mentioned that this thread pool is basically having the 4 threads, or we can increase it, but suppose our thread pool is having 4 or 10 worker threads, and if we are using all those worker thread for each request, we are creating one worker thread, or we are taking the worker thread from the pool, then after few requests all those thread threads from the thread pool will get occupied, and thus there will not be any thread remains in the thread pool. And thus what will happen, that for any other task or any other new request, that CPU or IO intensive work will have to wait till the one thread will be available in the thread pool. Now, creating the multiple custom threads require the extra overhead of managing the memory and thread creation and thread destruction process. So it will take a little bit time in your application, and that thus it may affect the throughput and latency in your applications. So we should be very conscious when to spawn a thread and when not to spawn a thread. So this decision we will have to take very wisely to keep our application robust, to keep our application very performant. So this is all today I'm having to discuss with my viewer, and it's humble request to please try this example and let me know your experience with the thread pool or worker threads in the comment sections. So thanks for watching this video.